Hello everyone, welcome back to my YouTube channel Physics Unification. In the last videos, we discussed so many topics from the chapter Ray Optics and Optical Instruments. If you have not seen those videos, I already attached part 1 and part 2 links in a description box. Please go through it. Today we can understand the next topics from the chapter Ray Optics and Optical Instrument. First of all, what we have to know? That one is total internal reflection. Then what do you mean by total internal reflection? When light ray which travels from one medium to another medium, that is denser medium to rarer medium, then the angle of incidence is greater than the critical angle. What happens? The ray of light which is totally reflected back into the same medium, that one is denser medium. Then it is said to be that ray is totally internal reflected by that surface. There are two conditions are there for total internal reflection. First one, it is a ray of light, it must be travel from denser medium to a rarer medium, and here in the second condition the angle of incidence in the denser medium must be greater than the critical angle for the pair of media. In sparkling of diamonds, in total internal reflecting prisms, and in optical fibers, and in mirages, we can see the applications of total internal reflection. And this definition, conditions, and application, those things are important for 2 marks. Definition is important for 1 mark. Next one concept, it is refraction at a spherical surface. That one is the derivation of the relation object distance u, image distance v, refractive index n, and radius of curvature r. Let us consider a spherical surface nm and O be the object which is at a distance of u from the pole. When ray of light which is incident on the spherical surface after refraction, which forms image at I, and V be the image distance from the pole. Here C be the center of curvature and R be the radius of curvature from the pole, and I be the angle of incidence. Arrow mark is important here. And R be the angle of refraction. Here N1 is the one medium and N2 be the another medium. Now apply tan theta to the triangle NOM. Then tan NOM, which is nearly equal to NOM, which gives opposite side. That one is MN divided by adjacent side OM, which gives tan NOM is equals to MN divided by OM. In the similar way, tan NCM, which is nearly equal to NCM, and which gives opposite side, that one is NM or MN divided by adjacent side, that gives MC. In the similar way, tan NIM, which is equals to NM opposite divided by adjacent is MI. Here for triangle NOC, I is the exterior angle and NOM and NCM are interior opposite angles. By exterior angle property, what we can write? Exterior angle is equals to the sum of interior angles. That is, I is equals to NOM plus NCM m. Here NOM, which is equals to the value of MN divided by OM plus NCM, which is the value, which gives the value NCM is equals to MN divided by MC. Called it as equation 1. Similarly, here for NCM, here it is NCM. This one is the exterior angle, which is equals to the sum of CNI plus NIM. Means exterior angle is equals to the sum of interior angle. That is NCM is equals to CNI plus NIM. Here what we have to find out? We know the two quantities NCM value, that is NCM is equals to MN by MC, and NIM value, that is NM by MI. So what we have to find out? Value of NCI by this equation. So which gives NCI is equals to NCM minus NIM, because this NIM when it is comes to other side, which gives negative sign. So here R is equals to NCM which gives the value MN by MC. So NCM is equals to MN by MC minus NIM, which is equals to NM by MI. Now from Snell's law, which gives N1 sin I is equals to N2 sin R. Here sin I, which is nearly equal to value of I, because I is very small, so just take sin I as I. N1 I, which gives N2 R. N1, in place of I, we have to substitute the value of I, which gives N divided by OM plus MN divided by MC, which is equals to N2 into value of R equal to MN by MC minus NM by MI. Here MN is common from all the terms. So what I will take? Here MN is common, just take outside, which gives MN in bracket 1 divided by OM plus 1 divided by MC, which is equals to N2 into MN 1 divided by MC minus 1 divided by MI. Here MN gets cancel each other. N1 into remaining terms 1 by OM plus 1 by MC is equals to N2 into 1 by MC minus 1 by MI. Here value of OM is equals to U, and which is on left side of the spherical surface. So by sign convention, the object distance which is on the left side of the spherical surface, we can take it as negative. So which gives N1 into 1 divided by minus U plus 1 divided by MC, which is on right hand side, which is equals to value of R is equals to N2 into 1 by R minus 1 divided by MI is value of V. Now just by multiplication of N1 to the this term and N2 to the this term, what we will get? Minus N1 by U plus N1 by R, which is equals to N2 by R minus N2 by V. Here just collect R term on one side. Minus N1 by U. Here negative sign, when it comes to other side, becomes positive N2 by V, which is equals to N2 by R. Here it is positive. When it is comes to other side, it becomes minus N1 by R. That is N2 by V minus N1 by U is equals to N2 minus N1 divided by R. And this one is the relation between object distance U, image distance V, refractive index N, and radius of curvature R of a spherical surface. And this derivation is very important for 5 marks, and they will ask problematic part from this derivation also. Next one, it is a refraction by a lens. That one is lens maker's formula. Here, what do you mean by lens? It's an optical medium bounded by two spherical surface. Here, consider a double convex lens which contains two refracting surfaces. Here, image formation can be seen in terms of two steps. At the first step, first refracting surface forms the image I1 of the object O. Here, this one is the first refracting surface. That one is A, B, C. Here, O be the object which forms image at I1. Which forms image at I1. Arrow mark is important here. And C1 be the center of curvature. Here, N1 be the refractive index of first medium and N2 be the refractive index for second medium. And I be the angle of incidence, R1 be the angle of refraction. R1 be the radius of curvature. Here BI1 which gives the image distance, OB which gives the object distance, N1 is the refractive index of medium 1, N2 be the refractive index of medium 2. This one is for the first refracting surface ABC. In second refracting surface, what happens? I1 itself, it acts as object for the second refracting surface. I1 itself, it acts as the object for the second refracting surface. That one is A, D, C, and which forms the image at I. Which forms image at I. Here C be the center of curvature. And here I2 be the angle of incidence and R2 be the angle of refraction. For second refracting surface ADC, here R2 which gives the radius of curvature. DI which gives the image distance. DI1 which gives the object distance, N2 which gives the refractive index of medium 1, and N1 which gives the refractive index for medium 2. Now apply N2 by V minus N1 by U is equals to N2 minus N1 divided by R. That one is refractive index for second medium divided by image distance minus refractive index for first medium divided by object distance is equals to refractive index for second medium minus refractive index for first medium divided by radius of curvature. Now for the In first case, what we have to consider? First refracting surface A, B, C. For first refracting surface, BI1 which gives the image distance, OB which gives the object distance, N1 which gives the refractive index for first medium, N2 which gives the refractive index for second medium. Here, now apply this refraction spherical surface formula to the first refracting surface A, B, C refracting surface. Then this formula which becomes refractive index for second medium is N2 by image distance is BI1 minus refractive index for first medium is N1 divided by object distance is OB is equals to refractive index for second medium minus refractive index for first medium divided by radius of curvature BC1. This one is the equation 1. For second refracting surface ADC, DI gives the image distance, DI1 which gives the object distance, N2 which gives the refractive index for medium 1 and N1 which gives the refractive index for medium 2. Now refractive index for second medium is N1 for the refracting surface ADC divided by image distance is DI minus refractive index for first medium is N2 divided by object distance is DI1 is equals to refractive index for second medium is N1 minus N2 divided by DC2. This one is the equation 2. This equation 2 can be written it as N1 by DI minus N2 by DI1. Here DI1 can be written it as BI1. BI1 which is equals to minus of N2 minus N1 divided by DC2. This one we can take it as equation 3. Now add equation 1 and 3. In equation 1 left hand side is N2 by BI1 minus N1 by OB, and equation 3 left hand side is N1 by DI minus N2 by BI1 is equals to N2 minus N1, that one is common in equation 1 and equation 3, just take outside, which gives 1 divided by BC1 minus 1 divided by DC2. Here N2 by BI1 and N2 by BI1 is common, just take cancel each other, then which gives N1 by DI minus N1 by OB is equals to N2 minus N1 into 1 by BC1 minus 1 by DC2. N1 by DI minus N1 by OB is equals to N2 minus N1 into 1 by BC1 minus 1 by DC2. Here, as OB tends to infinity, value of DI becomes F. And BC1 equal to R1, that is from first diagram, and DC2 equal to R2. This is by second diagram. Then this equation becomes N1 by DI means F minus N1 by infinity is equals to N2 minus N1 into 1 by R1 minus 1 by R2. Here 1 by infinity, which gives the value of 0, so it becomes 0. Then which gives n1 by f is equals to n2 minus n1 into 1 by r1 minus 1 by r2. Then 1 by f is equals to, finally what we will get, n2 minus n1 divided by n1 into 1 by r1 minus 1 by r2. That is 1 by f is equals to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. That is 1 by f is equals to n21 minus 1 into 1 by r1 minus 1 by r2. This one is the final expression. And this equation is called it as length makers formula. And based on this one also, we can solve the problematic part. Now we can discuss the problematic part of the chapter Ray Optics and Optical Instrument. Let us see the first problem. A convex lens of focal length 0.24 meter and of refractive index 1.5 is completely immersed in water of refractive index 1.3. Find the change in the focal length of the lens. Given quantity, they are given that the focal length of convex lens, that is 0.24 meter. What we have to find out? Focal length of water. And already they given that refractive index for convex lens, that one is Ng. Refractive index for glass is equals to 1.5, and the refractive index for water, it is 1.33. Now we know the formula, lens makers formula. That one is 1 by f is equals to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Now what happens here? N2, that one is refractive index for glass, n1 which represents the refractive index for water. In first case only we have to use convex lens. Here 1 by fg is equals to n minus 1 into 1 by r1 minus 1 by r2. This one is the lens makers formula. ಇಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಜಸ್ಟ್ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸನ್ನು ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಅಂದರೆ ಬಿಫೋರ್ ಇಮರ್ಸ್ಡ್ ಇನ್ ವಾಟರಲ್ಲಿ ಇಮರ್ಸ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಖಾಲಿ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸನ್ನು ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ದಿಸ್ ಒನ್ ಇಸ್ ಯುವರ್ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್. ಇಲ್ಲಿ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅಷ್ಟೇ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ವಿಚ್ ಗಿವ್ಸ್ ಓನ್ಲಿ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಫಾರ್ ಗ್ಲಾಸ್. Then 1 by fg. Fg means they already given, that one is 0.24, which is equals to 1.5 minus 1 into 1 by r1 minus 1 by r2. Now which is equals to 1 divided by 0.24 is equals to 1.5 minus 1, it is 0.5 into 1 by r1 minus 1 by r2. Let us take this it as equation 1. Now what happens? What we can take? Now just immerse that convex lens in a water ಮಾಡ್ತೀವಿ. ಇವಾಗ ಏನಾಗುತ್ತೆ, ಫೋಕಲ್ ಲೆಂತ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್? 1 by fw is equals to ng by nw minus 1 into 1 by r1 minus 1 by r2. So 1 by fw is equals to ng, that one is 1.5 divided by 1.33 minus 1 into 1 by r1 minus 1 by r2. Now 1.5 divided by 1.33 minus 1, value which gives 0.127 into 1 by r1 minus 1 by r2. Now we have one unknown quantity and 1 by r1 minus 1 by r2, that one is the common in both the equation. Now what we can take? equation 1 divided by equation 2. Equation 1 it is 1 divided by 0.24 is equals to, on right hand side it becomes 0.5 into 1 divided by R1 minus 1 divided by R2 whole divided by 1 divided by FW, that one is equation 2. On right hand side 0.127 into 1 divided by R1 minus 1 divided by R2. Here 1 divided by R1 minus 1 divided by R2, that one is the common in both the numerator and denominator. Let's cancel that one. FW divided by 0.24, which is equals to 0.5 divided by 0.127. Now what we have to find out FW. ಅದಕ್ಕೆ ಡಿನಾಮಿನೇಟರ್ ಇರೋ ಟರ್ಮ್ ಅನ್ನ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಮಾಡಿದಾಗ ಅದು ನ್ಯೂಮರೇಟರ್ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತದೆ. 0.24 into 0.5 divided by 0.127. So finally we will get 0.939 meter. So change in focal length can be written as FW minus FG. FW it is 0.939 minus FG, they already given the question, that one is 0.24. So finally what we will get 0.939 minus 0.24. ಡಿಜಿಟ್ಸ್ ಎಷ್ಟು ತಗೋತಿರೋ ಆ ಥರ ವ್ಯಾಲ್ಯೂ ವೇರಿಯೇಷನ್ ಬರ್ತಾ ಹೋಗ್ತದೆ. ಸೊ which gives the value 0.699 meter. Change in focal length, which is equals to 0.699 meter. Which completes the third part of the chapter Ray Optics and Optical Instruments. In the next video, we can learn the concept of thin lens, combination of thin lenses in contact derivation, and the refraction of light through a prism derivation, and the problematic part based on these topics. If you have any doubts on this concept, please drop a comment in a comment box. Stay tuned, like, share and subscribe my YouTube channel Physics Unification. Thank you.